Man, I like that tune. That's pretty cool. How's everybody doing tonight? Hopefully well. We're going to talk first in this video about a caveat with BGP and Azure that I learned about this week. I was involved in making some changes to production and found this out. So just want to kind of share this for anybody, in particular with ExpressRoute. So just to cover a few little basics here, and then we'll get into a little bit of logging. I'm going to try to illustrate this. Essentially, you have a number of ways to connect into Azure, right? It's great. You could build 100 virtual machines, but how do you connect to them, right? So there's multiple ways to do that. One, of course, is to expose your services to the internet. That's one way. And just connect to them from over the internet. But oftentimes you have, let's say, 100 virtual machines, right? Linux virtual VMs or Windows VMs, whatever the case may be. And one way to expose them, of course, is via creating VPN connections between Azure and your site or sites. A very common way for people who are doing proof of concept or who are learning about Azure to get started, right? Just create a VPN tunnel. And there are some caveats, but in general, you can VPN to an Azure, what's called a VPN gateway device, or say device. It's not really a device, of course, in Azure, right? So you can connect to a VPN gateway or multiple VPN gateways, and in general, it's going to connect with your Cisco ASA or whatever device that you're using. Like you would normally connect a site-to-site tunnel with any other VPN appliance, right? But another common way past that, as you continue to grow maybe your services or your use of Azure, another one's called ExpressRoute. And ExpressRoute allows you to basically connect directly into the Azure cloud. You have to use a provider. It's not Microsoft providing the service. But they have some providers that you can use, and a lot of the major ones like, Verizon Level 3, you would expect, CenturyLink, you'd expect, them to be able to offer a service into one of the Azure regions or data centers. And that ExpressRoute, it's essentially like a point-to-point circuit. There's also Azure WAN. There's some new services coming out. But essentially, ExpressRoute is a very common way. You can't play with ExpressRoute. Don't plan to do this using like a Virtual Studio subscription license. Obviously, ExpressRoute is something that generally an enterprise is going to set up. Just like you don't play around with just getting a circuit through Verizon, right? You don't get a business class circuit to your house to mess around with, or anyway. So with ExpressRoute, it's an interesting entity because let's say, for example, you have, and I'm going to try to draw this as I talk, and what I'm getting to is a caveat of BGP with ExpressRoute, because when you communicate with ExpressRoute, let's say you have ExpressRoute here and a Juniper or Cisco, whatever your router is on premise. Let's say this is Azure, right? Let's just draw a line here, for example, another line. And this is not planned to be real elegant, right? I'm just throwing this on the screen. So let's say this is Azure up here. And we can make this big, a little bit bigger. I'm just streaming this, folks. This is not, I know it's going to be on YouTube, but don't expect like a fully functioning diagram just to be ready and prepared. This is kind of spontaneous. So we've got Azure up here. Let's say you have in San Diego, for example, you have your on-premise facilities. Let's say you have like a call center out here or something, right? So this is Azure, this is San Diego, and what happens is when you provision ExpressRoute through your whatever provider you are using, Come on, move. I'm still kind of getting familiar with this draw IO interface too. They essentially will give you set it up depending on your configuration, but let's say we have through Verizon like a point-to-point circuit. Now Verizon is going to call that a service, right? Maybe it's a point. You may think of it as a circuit, but in reality, an express route circuit. And now this is Microsoft naming, right? Microsoft, I don't know why, has always had issues with logic when they name their products, but even Microsoft personnel engineers have told me this, right? So they call this product an express route circuit. But in reality, what you're getting anytime you order this service from Microsoft, it's not a single link. It's actually a minimum of 2 links that you're going to get. You're actually going to get 2 physical links handed off to you on this end from your provider, right? And Microsoft is going to provision, they essentially have 2 links in their POP, right? So an express route circuit is actually what we traditional network engineers would think of as 2 circuits, not just 1. But anyway, let's say you have just for all practical purposes, this is primarily a Cisco channel, right? Let's say you have a Cisco router and you're going to run BGP here. This is going, or you could have 2 routers, right? Generally you would have 2. So you have an express route circuit product from Microsoft, and then they would give you a primary and a secondary maybe. But you're going to have 2 circuits. You're going to get 2 physical links handed to you by your provider. So you'll have Cisco routers here, for example. Cisco is what I'm studying at the moment. So, and you're going to run BGP, and there's multiple ways that you can provision this circuit. So there's multiple types of peerings you can do on this circuit. Let me just put it that way. So there are 3 types, and one of them is currently deprecated. They still support existing peering types of this nature, but you have private peering, public peering, which is deprecated, and then you have what's called Microsoft peering. So what you can do with ExpressRoute is you can say, and let me try to fix this here. Yeah. So when you do private peering, what that means is that you're going to be able to run BGP. Azure's, Microsoft will create a peering point for this primary circuit, for example. And if you decide to peer on that link, to private peer on that link, what you will do is exchange routes with your private networks in Azure. So your VNets. So you'll have, for example, a VPN gateway here, a virtual network gateway, and then you'll have various VNets, what Azure calls peering, will peer to that virtual network gateway. And essentially you can have your private networks over here. The other type, which is deprecated public, but that type is now overtaken by what's called Microsoft peering. And if you do Microsoft peering, you essentially will peer with a different routing instance on the ExpressRoute product, ExpressRoute circuit, as I call it. Circuit. I'm going to put that in like. So what that allows you to do is can be your PaaS services. So over here, let's just say this is the Microsoft Global Network. And this is, public prefixes for many of their services. So think Office 365, think Azure Blob storage, application gateway, your whole host of PaaS services. This is moving up stack, right? Well, what you can do, so for example, let's say I provision an Azure storage account here, blob storage account. That's a great use case for often early adoption in Azure is storage. We just need a bunch of storage that we can expand basically infinitely. And depending on how you provision it, maybe you want multi-region availability of that storage account, redundancy. So very, very easy to start using in Azure. But what's going to happen is they're going to give you a host name or a URL to access that storage in many cases. And that's going to resolve to public IP, one of Microsoft's prefixes that they own. So let's say I have a server over here and I want to access that storage or a database. I'm going to have to go over the internet, right? Well, not if you provision. That's what this Microsoft peering does. And it's completely separate, right? Think of it as a separate sort of routing instance over here, BGP. And what Microsoft will do is they'll exchange with you. Now, this is theoretical here, right? You could have I'm not saying you would do this, but you could have other equipment in play here, right? Like a firewall. But what happens is with Azure, so they can send you prefixes. Let's say you peer on this secondary link here, right? Yeah, let's do that. So let's put a firewall. All right, so they can send you prefixes for, let's say we have, just as an example, 13 dot, what do they use? They have like 128. I think they have a lot of the 13 range, 0.0/16, for example. So they'll send you this prefix. And what you can do is you can say, all right, instead of going out over the internet to get to that blob storage, over the wild of the internet, right? You cannot really control what's going to happen on the internet. Oh, hey, we got mentors. Sup, buddy? Glad to catch you tonight. Lab tomorrow as well. Yes, I do plan to lab tomorrow, mentors. Oh, sure, my friend. Good to see you. So yeah, they'll send you a public prefix. So they'll route their, and Microsoft is, for Azure, AS12076. BGP AS number 12076. With Azure, as far as I could tell, whether it's a virtual network gateway or whether it is a express route circuit, they support BGP. So yes, you can peer. You can take a Cisco router here or a firewall, for example, and you can peer with BGP, and you'll get this 13.128.0.0.16 prefix, right? So you can then advertise this. Of course, you'll want to be using firewall here, right? But you can advertise this, and now instead of going out to the internet, you can just reach that prefix over this express route circuit. Much more reliable connection than the internet in most cases, right? So that's the beauty of it. They will basically take these services and, inject those routes into your network, so you have this point-to-point link to get to them, or links. It's great. It's a great product. I love it. It's a good product. It works well. Been using it for a while. But I discovered a caveat, and that's why the title of this is A Cautionary Tale. And there's a couple things going on here. So first of all, this is not a traditional router. Nothing of what you may think of as on-premise in terms of networking is traditional networking is going to be the same. You can't expect it to be exactly the same, right? In a cloud provider, it's just a whole different. A lot of other things are going on under the scenes, right? I happen to know that Azure, for example, Azure has a product called Service Fabric, Service Fabric Cluster, and watching a demo from Ignite, like at a base level, like the global network of Microsoft is using Service Fabric clusters. So aside from all the other things that they're doing, that's interesting, but this is not going to be the same. However, the fact that they're offering you BGP peering, you would expect that it would behave like a standard, the standards of BGP are, but don't assume. And I found that out the hard way. And I'll explain kind of in a general way. I won't go into a lot of specifics, but I'll explain in a general way how that happens. So first of all, think about this. So let's say you have this side, this link is dedicated to your virtual network traffic. Let's say you've got a sandbox over here, whatever the case may be, and you've got a sandbox on premise, and they're talking to each other over this express route circuit, and they're using, obviously this is private peering, so this is all private address space. This is like an extension of your WAN here. And this is not linked to the Microsoft Global Network directly at all. Logically speaking, this is two completely isolated things. But let's say, for example, in your routing down here, so let's put a router down below here. Call it DMZ, call it whatever you want, right? But what the point I'm getting at is, so let's say, you go through your firewall, but you're also sending all right, so let's put ourselves at this. It could be an ASA, it could be a Cisco router, it could be Juniper, whatever. This is all BGP. And let's say that this is Microsoft peered, and this one is private peered. And what happens in Azure, so this router here is always going to be AS12076. So think about the potential problems here. If BGP is not following the rules that it should follow, right? So let's say, for example, one of the rules of BGP, there's a loop prevention mechanism in BGP, and it is referred to in this standards document here, RFC 4271, for example, BGP 4. If the AS path attribute of a BGP route contains an AS loop, the BGP route should be excluded from phase 2 decision function. I'll try to blow this up. I know this has been kind of small to read. AS loop detection is done by scanning the full AS path as specified in the AS path attribute and checking that the autonomous system number of the local system does not appear in the AS path. Simple, right? Operations of BGP speaker is configured to accept routes with its own autonomous system number in the AS path are outside the scope of this document. So, again, let's say you have here 12076, right? AS12076. And here in San Diego office, let's say on this side that we have, AS11 or 65001 65112. And this is private peering, right? Let's say it's 65113. And let's say this is another site, or this is maybe a core 65111. Okay. So here come your, so here's like a database. And what you do at some point, if you go into Microsoft Peering, so this database is going to connect to Azure Blob Storage, a PaaS service. You have to use a public prefix here, right? So you on this BGP peering link, you're going to advertise an AS number, address space from an AS number that you own, 65112. That's an internal, but let's say it's something else, right? Let's say that I own 6511. Six five one two. Let's say this is internal, right? So when you advertise to the Microsoft Global Network, it's going to be like a normal eBGP. So you have to own this AS number. You have to own the address space that you use. Let's say, for example, we were really powerful. We had 8.8.8.0/24, right? So that's what I'm going to advertise into the Microsoft Global Network. And when I go this way, I'm going to NAT, right? Maybe my firewall NAT, maybe my router will NAT. But we're going to look like 8.8.8. Whatever to Microsoft. And it's going to route back. And that all works great. That's cool. Okay. Meanwhile, on the same express route circuit, it really doesn't matter. It could be any express route circuit. It can be an express route circuit connected in your Detroit office, for example. Azure is always going to be 12076. Okay. And that is documented. That is on their documentation. That's their Azure AS number. So you're going to get routes down here, AS12076. Okay. So let's say, for example, that you have private address space here, and you're doing BGP. You're also advertising BGP pack to your core over here because your core links off to your test bed or whatever the case may be. That is 10.2. So you're going to get BGP routes in here, and if you've got BGP here at this stage, maybe you redistribute into your local network as something else, as OSPF or EIGRP or heaven forbid RIP. But at this stage, BGP is here. Now let's say that your Microsoft public prefixes also get advertised back into Azure Express route to your private peering. Okay, so that you have a virtual machine over here that needs to get to Azure Blob Storage. Well, instead of using the Azure like backbone to get there, this router now has, he says, hey, I can get to Azure Blob Storage going this way, right? So it's going to go this way, this way, this way, and out and back. What should prevent that from happening? Can anybody think of that? I need lab possibly, so maybe I can load mine up and play with you. Yeah, just let us know which lab. Also, thanks for the Adam from the future stream. The guys motivate, enjoy his vids. Yeah, good vids, mentors. Definitely we'll let you know on that for sure. So the loop prevention mechanism, like we were talking about, should prevent that, right? Because, and I won't go into all the details of routing in Azure and how that works, like for this virtual machine here, but let's just say that, you know, in lieu of, if I'm not sending a default route, all balls 0000 this way, he's going to have, by default, he'll have a route to the internet through Azure's internet, right? So by default, he should be getting here to get to Azure Blob Storage. He should be using the Azure network. But if this AS path was working properly, this route would not even be seen as valid here for this virtual machine. Why? Because first of all, it would advertise 13.128.0.0.16. It would have 120.76, 6511, 65111, 6512, and when it gets here, a correct implementation of BGP would say, hey, that is an AS loop. That is an invalid route. Don't add it to the routing table. Well, guess what, folks? That is not what Azure does. That is not how Microsoft implements the BGP protocol in ExpressRoute. And there was an issue that was peripherally related to that. Granted, if the route does not belong going this way, it should not. And, you know, that was very easy to remedy. But it's not something I would normally, I don't know, it took a while to sort of nail this down, that this traffic was happening, just because, you know, in the back of our heads, right, we know that if you happen to have leaked routes coming this way, BGP knows that that's a loop for all practical purposes, and it's going to ignore AS12076. It's going to ignore those routes. It's going to say they're not valid, that it is looped. It does not do that. I don't know why, but I am putting in a feature request. I haven't figured out how to do it yet. Microsoft support is working with me to try to figure out how to do that. If anyone watches this video can tell me how to do that, please tell me where I can submit a enhancement request or feature request for BGP in Azure, because in the Cisco world, for example, there is a way, as it mentions here, operations of BGP speaker is configured to accept routes with its own autonomous system number or outside of the scope of this document. This is the BGP4 standards track. You can do this in Cisco world with the allow AS path command, I believe. Allow AS path in, something like that. So you can override that function, but by default, that is the loop prevention detection. And it appears that is not operational on the BGP in Azure Express route. So anyway, I just wanted to share that in case anyone is in the same boots as I've been, and I can help prevent that. I'm going to try to follow up with Microsoft. I would not think you'd want that as your default behavior. As a matter of fact, I would think if you decide to implement a routing protocol that has been around for a long time and that has publicly available standards documents, and maybe they have a very good reason why they did not, but I don't see one. To be fair, maybe there is something there that I don't know about. Maybe they've seen this before. They decided to leave it because it breaks other things, because of how they're doing networking. I don't know, but man, I would have liked to known about that. So lesson learned going forward for me anyway is if someone says that they're implementing BGP, check, double check, triple check certain behaviors, because don't assume that the vendor is going to follow the published standards of a protocol that has been operating pretty much the same on the internet for a long, long time. Anyway, it was fun in some ways it was not. But anyway, that is a cautionary tale about BGP and Azure. Now, blog about CCIE journey, which is why we're here. I am in day 418. It's been going well. Did not get a lot done today. Today was supposed to be a trip to the beach. There were threats of thunderstorms, so instead, I didn't go to the beach. I stayed home and I did my Marie Kondo. I cleaned out. I'm on like phase 3 of 4 or something like that, but it was something I needed to take care of. Took care of that. Gone through some flashcards, and tomorrow I hope to go back to. Let's pull up the INI workbook here and see where we are at. Safari browser. And of course, we're doing QoS. I think I decided, was it Wednesday night, that I really was not ready for this LOQ and remaining bandwidth reservations. Yeah, we may take this on, but mentors, if you're still on, I'm really behind in QoS. I've gotten like 4 labs done in a month. I've done a lot of studying though, but man, it is a struggle. So I'm just going to keep working on that, and then come back to reviewing, to doing the foundation labs once I get more caught up on QoS. So that's the plan. So I hope you're having a great weekend so far. Keep on labbing, keep on learning, keep on, pushing the good bits out. I finally had a chance today to listen to this interview. I've been catching up on a few YouTube videos out there. This is David Bomble's interview with Katherine McNamara. Very inspiring. A leader in the community, a role model for a lot of people, and someone I hope to meet at Cisco Live. She's on my list. I got to meet so many people at my last Cisco Live, and I didn't get a chance to meet her yet. So anyway, she's also in the Router Gods community. So I hope to meet in person. But great, inspiring story here. Definitely check it out. Also, Denise Fishburne, I mentioned her interview was awesome. It was great in the last, I think it was Wednesday night or Thursday night. Yeah, I'll be attending one of her sessions as well. But thanks so much for hanging out with us tonight. Good to see everybody. And we shall see you tomorrow. Do some labbing here on a LAN Tamer stream. And we'll see you in Discord. Have a great night.